Now that we've covered the basics of autoscaling groups, let's dive into the implementation details. In this demo, we're going to be scaling the dogcat classification app for Project 1 to handle higher loads through manual intervention. Here, I've logged on to the AWS account to access my AWS console. On typing EC2 on the search bar, I can get access to the AWS service, EC2 service. And on the left pane, I'll click on Autoscaling Groups and create an autoscaling group. Here, I'll specify the name of my autoscaling group. After providing a name for the autoscaling group, I need to specify a launch template for the autoscaling group. A launch template is a template followed by all the EC2 instances of the autoscaling group. Since I don't have a launch template predefined, I have to create a launch template. So let's go ahead and do that. Here, I'll specify the launch template name, the version description, and the template tags. Each launch template needs an AMI, and I'll specify the AMI that has the dogcat classification app preloaded. Please note that you need to be on US East 1 region to find this AMI. The AMI ID is CMU-15719-P11, and this will be found on the Community AMIs tab. After this, I'll specify the instance type as cfi.large, since that will be sufficient to serve the needs for my dogcat classification app. The next important configuration is the network settings, where I'll need to specify a new security group that the EC2 instances need to be a part of. The security group will be part of the default VPC in the US East 1 region. Here, I'll specify the security group name and the description. Since the dogcat classification app is configured to listen to requests from port 80 and port 8080, I will configure two security rules for those. And for simplicity, I'll specify that the EC2 instances can receive requests from any IP addresses, which is ideally not recommended. Here, I will maintain the default storage volume configuration associated with the launch template, and I'll specify the resource tag. Since the autoscaling group has the ability to leverage CloudWatch metrics and autoscaling metrics to scale up and down, we need to give EC2 instances the ability to publish metrics to CloudWatch. To enable this, we need to specify a new IAM role and a policy associated with the role. So let's go ahead and do that. Here, I'm going to create a new policy. For policy, I'm going to provide permissions for three services: EC2 Autoscaling, CloudWatch, and CloudWatch Logs. For simplicity, I'm going to give the EC2 instances permissions to all actions within each of these services on all AWS resources, although one may need to follow the policy of least privilege in practice. After this, I'll specify the policy name and the description. And now I'll review the permissions that I've defined as part of this policy, and I'll go ahead and add a tag for this policy as well. Once I'm done creating this policy, I need an IAM role to which this policy needs to be attached to. So let me go ahead and create that. The IAM role needs to be of an AWS service trusted entity type, and the use case must be for EC2 instance because we are working with EC2 instances in our autoscaling group. And here I will go ahead and attach the policy that I have just created. And I'll specify the role name as well. After this, I'll go ahead and create the role. Once the EC2 role has been created, I'll go ahead and go back to my create launch template page and I'll refresh. And I'll select the EC2 role that I've just created. And the last step here is to select detailed CloudWatch monitoring and enable it. Once this is complete, I will go ahead and publish the launch template. Now that we've successfully created the launch template, let me go ahead and select this in the autoscaling group creation page. Now I'll go ahead with the rest of the autoscaling group workflow. For autoscaling group, we need to configure it to use the default VPC associated with the US East 1 region and specify 2 availability zones for high availability, meaning that the EC2 instances can be spread across 2 availability zones. So I'll go ahead and do that. The next step is to create a new ALB. I will create a new application load balancer and make it an application type, and I'll go ahead and make it internet facing since it needs to be public and needs to accept requests from any IP address. Once this is complete, I will also specify and configure the target group such that once the load balancer receives a request on port 80, it will go ahead and forward all of the requests to the target group that contains all of my EC2 instances. I'll also go ahead and specify the tag for this load balancer. Once this is complete, I'll turn on the elastic load balancing health checks option and enable group metrics collection within CloudWatch. Now we need to specify the instance number range for our autoscaling group. For now, I'll specify the min and max to be 1 and 4 EC2 instances respectively. But the desired capacity will be maintained at 1. Over here, I'm going ahead with choosing no scaling policies, but there is also an option to create a custom scaling policy based on the CloudWatch metrics that are being published. And this is something that you have to explore as part of project P11. So I'll go ahead and skip these. Once we've reviewed all of the details, we can go ahead and create the autoscaling group. Now that we've successfully created the autoscaling group, let's go ahead and review the activity. As you can see here, since we defined the desired capacity as 1, the ASG has created just one EC2 instance behind the ALB. Here, you can also review the monitoring tab, which shows all of the autoscaling and the EC2 metrics that are published by the EC2 instance to CloudWatch.